All right, so we're going to look at our first section in chapter 10. Okay, we're only going to do 10.1 and 10.2. There's some other sections, but we really don't need to go through them. And it talks about solving systems. Okay, 10.1, we're going to look at solving systems using elimination and substitution. 10.2, we look at using a matrix. If we have a little time at the end, I might show you what a matrix is today, but I don't think we're actually going to do anything with it. All right, so basically, a system of equations, you're solving two or more equations for two or more variables. Generally, the type of systems we solve, you will have as many variables as you do equations. Two equations, two variables. It doesn't have to be set up that way. Okay, if you have more equations than you do variables, you can run into some interesting problems. If you have more, the other way around, if you have more variables than equations, you get kind of the opposite. So here's an example, more variables than equations. Okay, there's infinitely many solutions to that. 2 times a number plus 3 times a number equals 0. Okay, you could, again, infinitely many solutions. If you had something the opposite of that, you've got more equations than you do variables, it's possible you have no solution. Right? So we might take a look at a no solution today. We'll see. All right, this one, for now, I'm just going to set it up, and then we'll talk about substitution, then we'll come back and solve it. Okay, find the length and width of a rectangle if the perimeter is 100 and the area is 300. What's one thing I need to know here in order to set up these equations? Yep.
The area formula of a rectangle?
Yeah, I need the formula for the area of a rectangle. Okay, and what is area? Area is length times width. Now, if that's the only equation I had, this is an example of an equation with more variables, or a system with more variables than equations. Infinite answers. Any two numbers that multiply to give you 300. But the second part of that is going to narrow down how many solutions we get. What's the formula for the perimeter of a rectangle? 2L plus 2W. Okay, now because of this second equation, we have two equations, two variables. We're going to get one solution. Okay, there'll be a length and a width that makes this work. Okay, we'll come back and solve it in a little bit. But any questions on that? All right. So the two methods we're going to use to solve things are substitution and elimination. Sometimes elimination I think is faster depending on how the equations are set up. This particular problem, I don't think you could use elimination on it. You'd have to do it with substitution. And that's the first one I'm going to talk about. Right, so idea with substitution. You get two equations. Okay, pick one of them and get a variable by itself. It doesn't matter which equation you pick. Doesn't matter which variable you pick. Pick one equation, get the variable by itself. Once you do that, you're going to plug that result into the other equation and simplify. Right, so I think substitution is more confusing to explain it than it is to just do it. Okay. After step 2, you're going to know one of your answers. Either the length or the width, it depends on what you solved for in step 1. Then after you get one of your answers, you plug that answer back into one of the equations and you can get the second answer. Okay, so those are the basic steps with substitution. So let's try those steps with this problem. Okay, this is probably not a problem I would start out with in Algebra 1. Bless you. Okay, especially because of what's going to happen when we solve it. Okay, you'll see what's going to happen when we solve it is going to involve algebra, possibly Algebra 2, end of Algebra 1 stuff. Okay, yep.
So you say the xy equals 300, just divide by either x or y?
Yeah, I'd take the xy equals 300. That's the easiest one. to solve for a variable. Okay, so what do you want to solve it for, x or y?
Let's do y.
Y? And you know, I think I used L and W. It doesn't matter. We can keep x and y. Okay, so y equals 300 divided by x. Now, what do we do with that? Yep. Plug it in for y. What's 2 times 300 over x? 600 over x plus 2x equals 100. All right, what would I do next? I would do something with denominator, but even better than finding a common denominator, just get rid of the denominator. Yeah. Multiply by x. So we get 600 plus what? 2x squared equals 100x. Okay, so now maybe you can start to see why for a problem on substitution, not a good first problem for Algebra 1 because of how we're going to have to solve it. Let's get it equal to 0. So how would I move the 100x over? Yep, subtract it. And before I even try to solve it, what could I do to make things a little easier? Yeah, we could divide everything through by 2. Minus 50x plus 300. And one other thing we have to mention that we just did in the last couple steps ago, we multiplied everything by x. Okay? Because we multiplied by a letter, we have to check for, does anyone remember that? Yep, we just have to check and make sure we don't get an extraneous solution. All right. In the last class, we tried to factor. This doesn't factor. Okay? You can't find two numbers that multiply to 300 and add to 50. Okay? Or at least two integers. Okay, so how do we solve it if we can't factor? Okay, and somebody remind me what that is? Negative b. Yeah, sounds good. Over 2a. Okay. So we'll need a calculator in a little bit because I don't think the square root comes out nice. What's 4 times 300? 1200. And what's 2500 minus 1200? 1300. Okay, so now we'll type that in, and we have two possible answers. And we're solving for x. So x could be, we've got 50 plus square root of 1300 and divide by 2. So 43.03. Or, okay, let's type it in as a minus. All right, so 50 minus square root 1300, which is still positive, so we can use that. Divide by 2, so 6.97. Okay, those are my x values. Now, besides x, what do I have to go back and find? To find y. Well, I've got a formula right there. Just take 300 divided by x, and that's y. Okay, so let's find y. Let's take 300, and we're seeing where they cross. So one-dimensional shapes in a 2D plane, right? Graphing lines. What are we graphing here?
3D.
We're graphing in 3D. And the shapes we're graphing are how many dimensions? 2D. Okay, we're graphing planes in 3D space. So we're basically seeing where three planes intersect. Okay? So visually, that's what we're doing. We're graphing 2D things in 3D space. But we're going to stick with elimination to solve it. All right, I'm going to call this equation 1, 2, and 3. Okay, anytime I write a number on the board circled, that's going to represent an equation. All right, so we need to pick two equations, and we need to eliminate a variable. Okay, you want to get rid of x?
1 and 3.
1 and 3.
Okay, we're going to take equations 1 and 3, and what do you want to get rid of?
X.
The x. Okay, fine. It's always good to pick an equation that has a coefficient of 1. Then you know you won't have to use fractions. So what would we do to get rid of x using equations 1 and 3?
Multiply equation 3 by negative 2.
Yep. We're going to take equation 3, we're going to multiply it by negative 2, and we're going to add that to the first equation. Okay, so let's take equation 1. And what's negative 2 times equation 3? Yep, negative 2x
Minus 8y
minus 8y.
plus 6z
Yep.
equals 16.
16. Okay, we'll add these up. We're going to have a new equation. I'll call that equation 4. Okay, what's equation 4 going to be?
Negative 5y. That's what you come. Okay. Plus 5 is equals 50.
Equals 15.
So you got
Now, actually, you know what? Before we finish that one, what could we do to make that equation even a little simpler?
pull 5 out.
Yeah, let's divide everything by 5, and I'll call that equation 4. Negative y plus z equals 3. Okay? If that's all we had, we couldn't figure it out. Two numbers that add up to 3, infinitely many solutions. All right. What two equations did we use to get equation 4? 1 and 3. So now we got to get rid of x again, but we can't use 1 and 3.
2 and 3.
2 and 3. Yeah, I think 2 and 3 would be good. How would we do that? Times equation 3 by negative 3. Okay, we'll come back to equation 4 in a little while. All right, so we got 2 plus negative 3 times equation 3. Okay, equation 2, 3x minus 2y plus 2z. What's equation 2 equal to on the other side?
50.
15. Thank you. And then equation 3, we're going to multiply by negative 3. So negative 3x plus 12y. Can somebody tell me the rest?
Subtract 12y.
We're multiplying by negative 3, right?
Yeah.
Yep. So minus 3x minus 12y. Is that what I put? Oh, thank you. Okay. And plus what?
9z.
Okay, plus 9z. 24. All right, now add these up, and this will be equation 5. You don't have to number them this way. I'm just trying to find a way to describe what equation I'm talking about without pointing. So equation 5, x's are gone, y's. Yep, negative 14y
11z.
plus 11z equals 39. Now what am I going to do? There's a couple things we could do, but well, I don't care which way we do it. Yeah, go ahead.
Are we going to make equation, like use equation 4 and equation 5 and just solve for either y or z?
Yeah, use equations 4 and 5 and solve for y and z. You can use substitution or elimination. I don't know if either way is faster than the other. Okay, so do you want to use substitution or elimination? Elimination? Okay, what would you have, or in what variable you want to get rid of? We're going to get rid of z. So what would you multiply equation 4 by to do that?
Negative 11.
Negative 11. So multiply that by negative 11, and then add it to equation 5. Okay, negative 11. That's going to give me what?
11y
11y. Yep.
minus 11z
Minus 11z equals negative 33. And equation 5. Z's are gone. Okay, what do I get for my y's?
Negative 14.
now 25y.
Thank you. It is the negative, sorry.
Okay, then
Negative 3y.
Yep. Negative 3y equals 6. So what's y?
negative 2.
Okay, now we've got y. Go back up to either equation 4 or 5. Which one looks easier?
4.
Yep, I'd use 4. Fill in negative 2 for y.
So
Is that 2 plus?
Negative negative 2. Yep, becomes 2 plus z equals 3. What did I say? 2 what? Plus z?
2 plus z equals 3.
Is 3. So what's z? 1.
Oops.
If we had the 3 on the other side, then 2 plus 3 would be 5, but
Yeah.
this one's a little different. And now, last step, you've got y, you've got z. Go all the way back to one of the original problems.
That's y and z.
Let's see, there's other
Second number.
but this is
Which equation you want to use?
Actually, no.
And what variable are we solving for? Okay, so we've got x plus, what was it, 4y? What's y? 4 times negative 2? Negative 8. Okay, next part, negative 3 times, what was z? So negative 3 times 1, thank you. And what was on the other side? Negative 8. All right, so we got x minus 8 minus 3 equals negative 8. Negative 8 minus 3 is negative 11. So x is positive 3. Okay, so you can either leave your answer circled or write it as a coordinate. 3, negative 2, 1. Thank you. So this is the point in 3D space where everything crosses.
How do they find stuff? Like, how do they get the equations?
Yeah.
If this is, like, you said 3 planes crossing, right?
The 3 planes crossing in a single point. Yep.
How would they only cross 1 point?
Maybe I can find a 3D thing online. I can draw it easier. If I can, while you guys are working on the next problem, I'll see if I can find that. This must be something. On the calculator, we can't graph in 3D, so I can't show you on that.
You say you don't want to change the calendar during that time?
Yeah, we'll do that at the end. Thank you. Yes.
Still think we go through this.
All right, so try this one on your own. Okay, there's a, I guess, advantage you can use here if you look at equation 2. What's already eliminated? So just eliminate y in one other equation, and then you don't have to do it twice. It's already done for you once. Okay, so try that one on your own. If you should get nice answers. Okay, no fractions, no decimals.
So it'd be 2x minus z.
It'd be 2x minus z equals 6. You can think of it as 0y if you want. All right, so the last problem we did, I did find that, the graphing thing online. Not something we would probably try to do by hand, but it does, I think, provide a pretty good way of visualizing it, especially because you can rotate it. And the point, you can kind of see it, is right there.
That looks so good. It's still
Yeah. Okay, so there's your 3 planes crossing in one point. All right, so
that one.
what variable was already eliminated for us in equation 2? Y. So let's take equations 1 and 3 and also eliminate y. Okay, that's probably the fastest way to do it. What would you have to multiply equation 1 by to do that? 2. 2?
That's a word.
Wait,
I'm getting excited.
yeah, you're right.
So we're going to double equation 1 and then add it to equation 3.
Got it.
What do you get when you double equation 1?
2x minus 2y plus 2z equals 12.
Right? Equation 3, you could just put it right below it. 2x plus 2y minus z equals 12.
West cancel.
Y's cancel. What do I get for x's? Z's
Plus z.
equals 24. Okay. What equation do I want to use with that now? 2. Okay. Take equation 2 and equation 4, and you don't even have to do anything. Just add them up.
Get rid of z.
If you just add equation 2 and 4, look what happens. Can somebody remind me, what was equation 2?
Remember x,
2x equals
4, 6,
C.
6,
6.
6.
So 6x equals 30.
So 6x equals 30.
So x equals 5.
Okay, so x is 5. How do we get z?
Plug it in for 4.
Let's plug it into equation 4.
So 20 plus z equals 24.
What is it? 4 times, yep, 20 plus z equals 24.
Z equals 4.
So what's z?
4.
Yep. And last thing I need to solve for is the variable we eliminated,
Y.
y.
We're going to do problem 1.
Okay, x minus y plus z equals 6. So x, what did I say, minus y
Minus y
plus z?
plus z equals 6.
Okay, what's 5 plus 4?
9.
9 minus y equals 6. What's 6 minus 9?
Negative 30.
So what's y? Okay, so our coordinate is 5, 3, 4.
We still have smart.
We get it or not?
Okay, so solving a 3 by 3 system with elimination, not too bad, but an even faster way to solve it, and some of you might have watched me when I checked it on the calculator, is to use a matrix. Okay, what's nice about a matrix, which we're not going to look at today, but it saves a lot of writing. Okay, that's all I have to write to represent that whole left side as a matrix. The right side, 4 and 10. Okay, what's on the left? This is a 2 by 2 matrix. 2 rows, 2 columns. This is a 2 by 1 matrix. 2 rows, 1 column. Right? You could do that on the calculator. Yep. But how would you do it without? I would just eliminate the x's or the y's. Yeah.
No, but like, how do you do the 1, 2 by 1 pages on paper?
You know, I'll show you.
On paper, that we're going to look at tomorrow. We'll work with matrices tomorrow. Matrices really make a lot of things easier, and there's a ton of stuff you can do with matrices, but what's nice is once you learn like the 4 or 5 basic things you can do with a matrix, everything that's more advanced just depends on those 4 or 5 basic things, like everything. So in college, there's a class just on matrices. It's like a semester. It's like September to December. So it's like 3 months. And everything is on matrices, including what I'm showing you tomorrow.
Did you take that class?
Yeah, it's called
Was
linear
it horrible?
algebra. It's actually pretty straightforward. I think it's much, much better than like a calculus. If you don't like calculus, this is totally different, but it's still college level math, but nothing to do with calculus.
Before the meeting.
So most people like linear algebra. I mean, if you have to take a math class, it's not bad. Right, so homework tonight, okay, it's on 541,
Oh, that was cool.
okay, and it's 1 to 21 odd.
Yeah, but I don't like how it's not going.
Okay, tomorrow I will be giving you part of the test as a take-home. Okay, rest of the test we will do in class on Friday.